All right, there we go. We get to the streamlines on an airfoil. State what is meant by laminar flow, right? Laminar flow means that it's like they're laminate, right? It is like they're all parallel to each other. So laminar flow is like woo, woo. The velocities are parallel to each other and constant, whereas turbulent flow is like you've got a barrier and it's like spinning around. It's very turbulent, yeah? Okay. So yeah, there we go. That's laminar, right? And then it says the streamlines above the airfoil are closer to each other than the streamlines below. Okay, suggest why this implies that the speed of the air above the airfoil is greater than the speed of the air below the airfoil. Okay. Well, we want to talk about area 1 V1 equals area 2 V2, right? In that airfoil like that, how it's curved like that, the streamlines above are closer together, right? Whereas below they're further apart. Okay, so there's less area, therefore higher velocity. Okay. And then letter 2, the speed of the air is 64. This is a Bernoulli. Okay, so P1, we'll have this be 1, right? We'll have this be 2. Okay, so P1 plus rho GH1 plus 1/2 rho V1 squared equals P2 plus rho GH2 plus 1/2 rho V2 squared, right? Okay, ultimately the pressure below, of course, the air is moving slower, there's going to be more pressure there, right? So P2 minus P1 is going to be, we'll figure this out, right? Now, they say the airfoil is very thin. How thin? Well, it's very thin, right? So the pressure difference from the top to the bottom due to the hydrostatic pressure of the air is going to be negligible. That's what they want you to say, okay? And then basically P2 minus P1, right, is going to be equal to, let's see, 1/2 rho V1 squared. I'm just rearranging this, right? Minus 1/2 rho V2 squared, right? So just plug that in, this pressure difference we want to find, right? Okay, and then they give you the density of the air right there. So plug that in for the density. Right, and then V1 is the velocity above, which is 64, right? V2 is this guy, right? And you'll get a pressure difference that is, hold on here, a pressure difference that is like in the 600s of pascals, okay? So P2 minus P1 is roughly 600, right? Actually, it's roughly 700. It's right in the middle there. Okay, and then basically the force is going to be the difference in pressure times the area. They tell you the area is 2 square meters. So, there we go. And I got a force that is in the thousands. It's between 1,000 and 2,000. Okay.